All right, back with the same El Dorado Community College example, but I call this one part 2 because it's based on the rest of 6.2 notes on combining random variables, which meaning you have two independent random variables, and let's say you want to add or subtract them. Well, what do you do with their means? What do you do with their standard deviations? So that's what the rest of 6.2 is about. And I go back to the same example as my previous video on linear transformations. We start off with the same random variable x, and if you remember, x is the number of credits at this community college, and the probability is the probability a student takes that number of credits. So I have the same distribution. This is the same mean from the last video, the same standard deviation from the last video. But what's going to change now is we're going to add a second part here where there's a downtown campus that specializes in just a few fields of study. So full-time students at the downtown campus only take 3 unit classes. So now this new random variable y is the number of units taken in the fall semester by a student at the downtown campus. So the distribution's a little bit different. Obviously it's multiple of 3s because they're all 3 unit or 3 credit classes, and then the probabilities of each. To find the mean variance standard deviation of y, it's the same thing as we did for x. I just want to show you just to review. So if you notice, there's our stuff about x. I added in the y. So here on page 1.9 in my calculator document is y units and the probability of y. This is the downtown campus, the number of credits there, and then the probability of each. So if I want to find the mean variance standard deviation of that variable, I add a calculator page, menu, statistics, stat calculation, one variable stats. This time I want to pick the y units and the y probability. That's what I decided to call it. And if I look here, it tells me the mean is 15. And the standard deviation is 2.324 about. And if I go to my answer key, I think that's what I have for that mean and standard deviation. The variance, remember, is just the mean squared. Or I think it's the last thing that shows up on that calculator screen. Let me go to a blank copy of this. So now randomly select one full-time student. So I'm picking one kid from the main campus. That was X. And I'm picking one kid from the downtown campus. I'm going to add their number of units and call this new variable S. So what this new variable S is going to equal X plus Y. And if you took good notes or you read the book, to find the mean of S, or the new mean, is going to be the mean of X plus the mean of Y. And I'll write these formulas at the end of this presentation, but if I'm adding 2 random variables, to get the new mean, I'm just going to add their old means. So the mean of S, can't type this too quickly, but we'll just say US for mean of S is going to be the mean mu of X plus the mu of y, or the mean of y. So if I go back, the mean of x, let me scroll back up, the mean of x was 14.65. I'm going to add to that the mean of y, which was 15. And that's going to give me, what, 29.65 is the mean number of credits if you randomly pick a student from campus, the main campus, and add their credits to a student from the downtown campus. So pretty easy if you're adding 2 random variables, as long as they're independent. Here, there's no reason to think those 2 students are not independent. You just add their means. The same thing would happen if I wanted to subtract their credits. I would do the mean of X minus the mean of Y. So, the same formula applies for means. If you're adding 2 random variables, you add their means. If you're subtracting 2 random variables, the new mean comes from subtracting their means. Something that's a little bit different is finding a new standard deviation. Again, if you read the rest of 6.2 on combining random variables, it's a little bit unique. If I want to find a new standard deviation, I don't really do anything with the old standard deviations. I work with their variances. And whether or not I add or subtract two random variables, here we're adding x plus y. But even if it was x minus y, the new standard deviation is going to come from adding the variances and square rooting. So in this case, to find my new standard deviation of s, remember s was x plus y, or the credits at the main campus plus their number of credits at the downtown campus. To find the new standard deviation, it's called s now, I'm going to have to take the square root of their variances added. So the variance of x plus the variance of y, and then take the square root of that to find the new standard deviation. That's regardless. Even if it was x minus y, we would have taken the sum of their variances and the square root. And again, I'm going to write this with my stylus pen in a second at the conclusion of this video. But just to finish this problem, the standard deviation of s is now going to be the square root of the variance of x. I forget what that was. Variance of x was 4.23. Or you could have taken the standard deviation squared. Remember, if you didn't write down the variance, let's say I didn't ask you for the variance, you could have just done the standard deviation, 2 point whatever it was, and squared it. And then I'm going to add it to the variance of y. I'll show you with y, because variance of y, the standard deviation of y was 2.324. So if I wanted to take or find that variance, I'd do 2.234. Is that what it was? Hold on. Escape. 2.324. And I'd square that. So 5.401. And I'm going to square root that. Take the square root. So the new standard deviation of the sum of those random variables is 3.103. All right, I'm going to go through a part 3 version of this El Dorado Community College example, and I'll kind of just keep my solutions up here to save a little time. But part 3 starts off saying same community college with the main campus and the downtown campus. But now again, I have two new random variables. So my two new random variables, I'm going to underline them here. My two new random variables are B. That's the amount spent on books at the main campus. And they tell me the mean is, this is the cost of books for the fall semester, and they tell me the mean cost of books is 153 and the standard deviation is 32. Earlier, so again, last week's example, the video I sent, C was the overall cost of tuition and fees, and this was the mean and the standard deviation we found last week in this problem. If I want to know the total mean and standard deviation cost of tuition, fees, and books, so that's taking both those random variables and adding them, I don't have to actually go through and add all the individual values. I can do it using the formulas from 6.2, the second part. And let me write them at the top here. So if I add two random variables, we're going to say x plus y. I know this isn't x and y anymore. It's just in general. So let's say I have some random variable t, and that's going to be adding two random variables x plus y. Actually, let me make it even a little bit better. If I add or subtract, so x plus y or x minus y, the mean of that new random variable, if it's a plus, I'm going to take the mean of the old one and add it to the mean of y, so the mean of one plus the mean of the other. If it was a minus, so I added this minus in on purpose, I would also just subtract those means. So to find the new mean, you're either going to add the old means or subtract them based on what you're doing with the random variables. Now the standard deviation is a little bit different. So if I have the standard deviation of this new random variable, it's my dog in the background. The standard deviation of this new random variable is going to be, regardless if it's add or subtract, it's going to be the variance of the one, so sigma x squared, that's the variance, plus the variance of the other one. So even if I was subtracting to find the new standard deviation, I'm still going to add the variances. So that's what's a little bit unique. Fun fact and convenient for us, although I don't know how it works with the AP exam being online now, but this was a formula on the AP exam sheet. So you don't have to memorize that if you combine random variables, the new mean comes from either adding, subtracting. You don't have to memorize the new standard deviation was the sum of the variances. I'm not really sure how that works now that you're taking the AP exams online, but I mean, here you see the formulas and how they're going to work. So in this first part, if I want to add two random variables, I add their means to get the new mean. If I want to find the new standard deviation when I add two random variables, I add their variances, and then to go from here to here, I just took the square root of that. And let's scroll down to the last part. This last part's going to kind of involve some linear transformations as well. So at the downtown campus, full-time students pay $50 per unit. Let U equal the cost. I think we've actually already done this one. So here, if I find the new, no more adding or subtracting, here I'm multiplying 55 times the downtown campus. So $55 times the number of credits at the downtown campus. This is a linear transformation because I'm multiplying. So remember from last week's notes, if you're multiplying to find the new mean, you multiply the old mean. So I'm going to do 55 times the mean of the downtown campus. So the average cost of the downtown campus for tuition is $825. The new standard deviation, if it's a linear transformation, you also multiply. So I multiplied the old standard deviation by 55. So the average offset in cost is here from the mean. It is $127.82. In part B, what if you want to find the mean and standard deviation of tuition from both campuses? So main campus, that mean tuition was $732.5, and we just found the downtown campus was $825. So to find the new mean, the total tuition, I just add those means. That's it. So two random variables with their unique means. To find the sum, you just add their means. And then standard deviation, I take the square root of their variances to get the standard deviation overall. All right, one more before my 15-minute video limit's up. Suppose we randomly select one full-time student from each of the two campuses. What are the mean and standard deviation of the difference in tuition charges? So now I'm subtracting two random variables. Spotty. So first time in this video that we've had a difference of two random variables. So now we're doing the tuition at the main campus minus the tuition at the downtown campus. So to find the new mean, if I subtract the old means. Makes sense. If I want to find the new standard deviation, a little bit strange, I don't subtract at all. So even though the standard deviation is of a difference, I'm still going to find the variances, add them, and take the square root. So I mean, that's the key, the tricky part of this section is really just the standard deviation part. So just remembering means, subtract, means, add, you add. But what's really weird is this part about the new standard deviation. Regardless of if you add or subtract, to find the new standard deviation, you still add the variances and then take the square root. I hope this video helps clear up the rest of 6.2. Just send me a message in the remind if you have any questions.